Hello, good afternoon. I suggest to wait a couple of more minutes just for everyone to join. And we can start our today's webinar. Let's wait 1 or 2 more minutes so we can gather everyone registered. I can see people are joining, so let's give them a chance. Okay, I can see quite a lot of attendees already. A few more seconds and let's start the webinar. Okay. Hello and welcome on today's SDC webinar. My name is Michal Oleksy. I work at SDC as an application engineer. And today I will try to share my knowledge and our experience regarding the offshore compliance. As you can see on the screen, we'll talk about consistency and certification with use of SDC for Ansys. Today we will speak about challenges which we can see during validation of offshore structure. I will also try to share a couple of trends which we can see during the discussion with different offshore users of our software. I will try to highlight also some pain points in offshore validation workflow. And in the second part of the webinar, I would like to show you how you can automate checks, how you can utilize SDC with use of different FEA software, such as Ansys, for example, to simplify and make your life easier to improve your workflow and reduce of calculation time. At the end, I encourage you to ask also the question, and yeah, so let's start. First of all, quick introduction about our company. So we are SDC Verifier, and as you know or not yet, our company consists of two parts. One of them is related to developing structurals and simulation verification software, which name is SDC. Our software works with all popular FEA software such as Ansys, UMAP. We have also our standalone software. As you can see on the screen, at the moment, our company consists of more than 30 people. I think it's about 35 at the moment in 3 different countries, 3 different offices. More than 200 companies are already using SDC Verifier, which results in about 1,000 engineers. So as you can see, it's already widely settled in the industry. the results are recognized in many different countries and also for many different industries. The second part of our company is structural engineering consultancy. We have a couple of engineers who work also and share their knowledge. We work also on live projects, mostly in offshore heavy lifting industry. So thanks to that, SDC is not only the software developed by software developers, but we also have constant feedback from engineers who are using it every day, just for the regular work. So thanks to that, we can always introduce some user-friendly features and detect some bugs, for example, or or some improvement which can be done in terms of ease of use and make it more user-friendly, I would say, even engineer-friendly. Okay, here on the screen you can see different structures for which you can utilize SDC Verifier. As you can see, many lifting crane structures, shipbuilding, some smaller structures where, for example, fatigue assessment has to be analyzed, and of course, different types of offshore structure, topside, mud mats, from the global analysis through very small details where you have to comply with standards. You have to ensure that your part will meet the certification requirements, and you can use for this SDC. From our experience, which we see, and the trends which we see at the moment during our work with different companies from different countries, we can see that FEA tools are getting more and more popular within the industry. So at the moment, basically, there is no way to ensure that your structure is meets the standards, to calculate the structural in terms of structural strength, fatigue, weld strength, and plate backlinks without FEA tools. We always have to meet very short deadlines. We have to meet very strict rules where our results have to be, of course, accurate. So at the moment, the only way to do that is to use FEA tools, such as Ansys with SDC, for example. We can see that a lot of companies try to automate all the code checking. So it's not like it used to be. We have some spreadsheets, we have some manual work, where every time you have to repeat this process, or for example, regenerate the reports every time you have to do the same work. So we can see that a lot of companies want to reduce this time by automation. So if you have very repetitive processes or very similar structures where you can repeat those processes easily, automate them, that's the way where you should aim at the moment to fit these deadlines, to meet the deadlines, and to ensure your structure is always checked in the same way, so there is no way for an error. Another thing, weight optimization. Of course, now we talk a lot about environment, talk a lot about the prices of steel prices, especially. So we have to optimize our structure. It's not like we can over-design it and don't pay attention for the weight, for the material usage. We have to always have it somewhere in the mind. Another thing which is getting more and more popular, is live extension and retrofitting of existing structures, because sometimes it may be way cheaper for the customer to change the usage of existing structure, modify it, retrofit, and move it to other place. So there, it's even more complex, because we have to recalculate the structure, do some modification, taking into account new conditions, and usually we want to do it very quickly. So we have to pay attention on that and use the quickest possible solution. So here, FEA, automated code checking, can help us. Another thing, which is also very popular at the moment, is let's say digital twin technology. So in simple words, that can be a replication of your structure with digital twin, so model which replicates all the condition for which structure should be analyzed. And then you have always live results, so you can do some simple modification in the model as they were done in real life, recalculate, and you always are sure that your structure can meet the criteria which are set by certification society or some internal rules. Of course, there are a couple of main pain points in the offshore analysis. So for sure, these are environmental loads, or storm, wind loads, accelerations due to different movements or different actions on our structure. So that's one thing which we have to take into account when preparing the model, setting boundary conditions. Another thing which is often which we often have to take into account is fatigue. So due to repetitive cyclic loading, our structure can develop cracks, it can develop fatigue damage, which reduces significantly the lifetime of the structure where we can use it. So in order to extend the lifetime, that should be always checked and ensured that it meets the requirements. Multiple failure modes, another thing related to different loading conditions. There, how to take into account many different load combinations, how to deal it in quick way. I try to explain it in few minutes. Another thing, FEM model complexity. So often those structures are huge. We have many different members, different plates, different welds. How to efficiently manage it within your model, within your calculation? That's also another question. I will also try to answer it in the next slides. First of all, all the complex loading condition should be taken into account, as I said. So there are different conditions like wind, weight, wave load, tank ballast, buoyancy load, and so on. So we have to make sure that we can apply them directly through model, for example, with use of different tools, because doing it by hand, that can be very tedious and time-consuming work. Also, as I mentioned before, fatigue and buckling. So fatigue, as you may know, it's damage of structure caused by repetitive cycling loading, so different accelerations, some cyclic wave load, and so on. So which can cause the stress difference, the delta stress in our elements, which will result in developing of cracks. You will initiate crack, and then the crack, with every another cycle of loading, can grow further. So that's something which at first maybe not even noticed by by engineer or by maintenance crew on the structure, but with time it can cause a lot of issues, as often those cracks can start initiation somewhere in the places where we don't have visual access. So the only way to estimate where those cracks can occur, for example, for inspection, is actually FEA analysis. So from the results, we will see where the cracks may occur, in which part of the model, which element of the model, and then we can schedule inspections accordingly. Another thing, plate buckling. So in all the shell structures, plate structure made of steel, that's also a very serious case which we have to take into account. This may occur due to compressive load. It can be very sudden, so there is also a lot of danger of that our structure will stop its working, so it won't be able to work anymore, and we have to repair it. So it's, of course, we should avoid it and prevent it. Then we have also limitations of manual verification. So what the engineers used to do before, some of the companies still do it, is just manual verification with of some spreadsheets where there is really high risk of human error. Engineer has to read the results by himself, copy, paste, manage all those results. There might be thousands, millions of different outputs, different stress results, displacements, and so on. So it's almost impossible to manage all of this without the error. Sometimes you update the model, you have to re-update all those outputs for the calculation, and there might be the case where you forgot to add something. So that's very risky, I would say, for huge structures. And the other thing, that's time consuming, and it's really hard to handle multiple combinations. Another thing, it's also hard to represent the results. We can show numbers, but how to represent nice plots, nice pictures for your customer or even for yourself, for your internal usage. Last thing, of course, compliance to multiple standards. So, for example, with offshore buckling standards like DNV, API standards for tubular members, joints. These are the popular codes where a lot of structures should be calculated to. And yeah, the question is how to do it efficiently. And here we have SDC, which was, as I mentioned, which is the software developed for engineers, by engineers, to help everyone to make your life easier. As you can see on the screen, this is something which I mentioned. So SDC works as a plugin for Ansys, FEMAP, SimCenter 3D. Here we will focus on Ansys, but we have also this standalone separate version where you have our own graphical interface. Let's start maybe how to approach all those issues which I mentioned before. So if we speak about the use of SDC with Ansys, we can represent it with this simple diagram, which you can see on the screen. Let me try to maybe switch pointer. Okay, so first of all, you have to prepare your model. So the workflow with SDC for Ansys looks in a way that, first of all, you create your model in Ansys, you apply all the boundary conditions, constraints, loads, and then from now on, you can connect SDC and do all those processes which you can see here one by one, and automate all the workflow in order to improve your efficiency and reduce time. So after the model is prepared, engineer can perform load combinations according to different standards. All engineers know in every standard you open, there is usually a table with different safety factors, partial reduction factors, sorry, which we have to take into account. Sometimes due to many different loading conditions, directions, number of those combinations may grow to hundreds, even sometimes thousands of different combinations. So with use of SDC, you can manage them easily. Then we have recognition. So recognition is the tool which allows you to recognize different parts of your structure, such as welds, beams, plates, because we don't do checks on finite elements. So on single elements, we have to know where are the welds to calculate weld strength check, fatigue check, plates for plate buckling, for example, and so on. Then, as you can see, after those two steps, we can move to checks. So as you can see here in the middle, all those checks according to different certification society are added in SDC, predefined. So you can add any of this to calculation to your project, and then analyze the structure, whether they comply with rules set up in these checks. At the end, you can perform automatic documentation, predefine all type of plots, tables which you would like to see at the end, or you can use, of course, ready-made template, which is already pre-created in SDC. All those steps, as you can see, are made in circular form because all those processes are usually repetitive. So you prepare the model, do the first initial calculation. At the end, you see, okay, we have to update some part of the model. You go back to Ansys, update it, and then with one click, you can do all those steps, recalculate the model, regenerate the report. So you don't have to do it every time. Okay, maybe let's go one by one in details. So first of all, as I said, preparation of the model. So preparation of all the loading conditions, boundary conditions. With use of SDC, we have a tool which allows you to create wind pressure with different wind profile over height, with different drag coefficients on your structure automatically. So the wind will be exported directly to your Ansys model. Same with wave load. You can take it into account different coefficients for different members, plates, and so on, and apply wind load directly to your model, again, automatically. All those loads will be structuralized with use of SDC, and then you can also do nice tables with all explanation of all the load steps, all the steps which how the load was applied, which place, and again all of this can be done with one click. The next thing, there is also I have also a short video just to show you how to make the wind load profile. So as you can see, there is this simple window where you can specify vertical direction of your model, direction of the wind applied. Then on the bottom, you have possibility to create selection of the model. So you don't have to apply it for the full model. You can only choose selection, for example, above the water. Choose the wind profile from your database, create your own one, and save it, for example, and with use of that, wind will be applied to the model. The next thing are load combinations, as I mentioned. So in SDC, all the loads are structured in a way that you will see separate individual loads. So all the loads without any factors, which can be combined afterwards with linear combination with different factors from standards. Then we have load sets. So these are linear combinations, and also load groups, which are envelopes of the result. So load group can be created out of load sets, out of individual loads. So you can choose which loading conditions should be taken into account for certain standards, or for example, for fatigue checks. This, what you can see, is a typical table taken from standard. It can vary, of course, from different standards. We have different factors, different loading conditions, but the idea is same. The very basic way to do it, how most of engineers did it before, is to create it in Excel, copy paste this table in SDC. That's one thing. Or you can also use predefined load cases, and this is a way to do it automatically. Here you can see also short video how those automatic combinations can be created. So engineer can select the standard. Then the next step is to choose category for each load. So for example, gravity, dead load, some vertical forces, live loads, and so on. Of course, you can choose multiple conditions at once. You have also possibility to choose different positions of the load. So for example, if you have a wind load from different directions and you don't want to combine them into one load set, and you will see that software automatically takes all the factors and creates the set of combinations according to the standard which you have chosen. So that's also a quick way to do it. Another step is recognition. So here we have different types of recognition. First of all is joint recognition. This one can be performed for one-dimensional elements, and it recognizes all intersections and also reads from the model whether it's joint in one plane, in a three-dimensional plane, or for example only in one line. Then, if we speak about beam elements joints, the next step is to recognize beams. So out of this recognition, software reads the buckling length for each direction of the beam. So for example, in direction Y, we have full length. In direction Z, we will have this length split into where we have a joint. So that's how SDC works in this case. Then we have also recognition of welds, which can be used, for example, for weld strength check and for fatigue checks. And here we can recognize both shell elements, welds from shell model, and also three-dimensional model. So with solid mesh. Another thing is recognition of stiffeners and of plates. So here we take into account all shell elements. In case of plates, SDC reads the boundary of each plate, reads intersection between the plates, and also stiffeners, which are modeled with 1D element. And out of this recognition, we can use dimensions. Well, SDC will use it automatically. You don't have to do anything except pressing one button. But that's how it looks like. And here you can also see recognize stiffeners, which are modeled with 1D elements. Here you can see how to recognize all elements. So you can click one button, the progress, how fast is it, and you will see the window how many joints, beams, and plates were recognized. Each of the recognition will create a table with numbers for every part, and engineer has possibility to preview all of them with different kinds of labels, with number labels, with different colors directly in Ansys. So that's how you can easily manage all those recognized parts, figure out where you have which member, and then use this logic also for calculation, just to choose proper selection for the model which you would like to analyze. Here you can also see panel recognition. We can preview all the plate elements directly in the model. So as I said, these elements are recognized out of shell model. Then the next step would be also to show weld recognition. In this case, all welded parts between the shell elements. And as you can see, SDC also recognizes which part is welded, which part is non-welded. So that's something also what is very important, for example, when setting up the SN curves, notch classes, FAT classes, depending on the standard. If we would like to perform fatigue checks. Here, as a summary, you can see all the recognized elements out of the same model. So as you can see, this tool is also pretty powerful and makes your life easier and much faster. If we speak also about panel recognition, it's worth to mention that all the plates are sorted by planes. So for example, by Z, X, Y, and also custom. So these ones which are which do not belong to anyone, any plane. And in the table, you can manage all the sections. So the section is biggest part of the which consists of different panels and plates. And then section is divided into panels on every intersection of panels or plates. And each panel is divided into plates with beam stiffeners. Okay, the next thing, except recognition, is our checks. So here you have, in SDC, you have database of many predefined checks. As you can see on the screen, these are a couple of them. I'm not even sure how many we have at the moment. I think about 50, 55 different checks, different standards implemented. So that's one thing, how you can perform them. Just select from the database, add it to the project, and then calculate. But there is also another way to do that. It's worth to mention that all the checks in SDC are open for the user. So that means that if you wish to do this, if you have some time, you would like to learn something new, you can easily add a new check or edit existing one with use of simple formulas, using outputs from Ansys, so parameters, material data, property data, constants, so everything. I know it may look a bit complex at first glance, but in reality it's very easy. And if you can use Excel, then you can easily also add these formulas in this SDC check creator window. Okay, let's maybe now focus on some checks. Example for offshore structure. In this case, I would like to focus on plate buckling, for example. Later on, we can also discuss fatigue and joint check quickly, just to give you an idea how they work in SDC and how you can make sure that your offshore structure, meets the requirements. So, for example, if we would like to calculate the plate buckling check according to DNV. When you add it to this to the project, you will see the window where you can adjust different settings. So it's not like you add the check and then you just blindly follow what software told you. You have possibility to preview different results, also to adjust some things like thickness factor. For example, if you would like to increase just for calculation your thickness or decrease it to take into account, for example, corrosion, that's also possible. You have possibility to choose different selections for the check and also different methods to read the stresses. So the stresses can be shown used as average or minimum midplane, for example. It's also a possibility for an engineer to use different approach. On the left, you can see DNV, on the right, ABS. So in general, these checks are very similar. We have only slightly different, factors. Here you can see results of the DNV standard. As you can see, with SDC, you can plot the results directly to Ansys to visualize the results with you to show, for example, utilization factor of the standard and easily check all the parts. Of course, you can show it for full model, you can show it for separate sections. So for example, here it's shown just for the top part, or other sections hide it, so you can maneuver between those results in easily. Again, you can also show it with different kinds of tables, extreme, minimum, and so on. Maybe even just to give you a rough idea how quickly you can do it with SDC, I will quickly jump to Ansys and show you quick live demonstration how you can do it. We can even see how much time it will take me to recognize and calculate this DNV check. And I think you can compare it with hand calculation if any of the engineers still does it. So first of all, we have our model, as you can see, same as on the presentation. And then I can go to SDC. First step would be to recognize panels. I can go to the panel finder, click find, remove all the existing sections, just recognize it once again. As you can see, how quick is it? This model is not so big, but even for larger model, it should be fairly quick. I approve by OK, and then add standard which I would like to calculate. So let's choose DNV, for example, CG0128 plate buckling. Here you can see the same window. If you do it for second time, for example, you can already predefine all those settings which you usually use. So with one button, you can load them, approve by OK, and you're basically ready to preview results. So I can create quickly plot. The only thing which you have to do here is to choose loading conditions. So for example, I would like to see plate buckling results for envelope of my all load sets, which I created. And here, preview. On the bottom, you will see that SDC started calculation, and it calculates for all load set 1, load set 2, 3, 4. Of course, depending how many load sets you have, it will take longer or shorter. But in my case, I see that it's already done. And yeah, as you can see, it took me about 2 minutes to calculate all those plates. I don't know how many, probably around 100 plates. For each of them, I have already utilization factor and all the calculation procedures stored according to DNV. Also, with one click, I can generate the report and send it to my colleague or even to Certification Society. Going back to presentation, let's maybe jump to Another topic, which is fatigue standard. Here, if we speak about fatigue, it's always slightly more complex than simple plate buckling check, because we have to, first of all, specify correct classification for welds, for welded parts and unwelded for for full model. So here in the middle you can see the window for which where you have to specify some factors. Don't get scared by these tables. I just copied them from the standard as a reference, but in reality here you have to choose just whether your environment is air or sea. If you would like to use some stress factor, and whether your section is tubular or not. The most important is this table, so SN curves. If I go to the next slide, you will see that classification for the welds and for non-weld parts may be different. Of course, well, it has to be different for different conditions, for different direction of load, for different type of welds, and so on. So you can find these pictures in different standards, and they result in different classification for our model. So with use of SDC selector, you can easily create that, recreate that classification directly in SDC. As you can see, for example, for full model, I have higher class, and then for welds in X direction. So X direction will be always perpendicular to weld. So that's how SDC automatically transfers all the stresses in weld direction. So all the stresses are so X direction is always perpendicular to the weld, Y is always parallel, and so on. So thanks to that, you can easily set it up according to standard. So for example, if we speak about X direction, you can see that here I set up C1 for welds, B1 for all the model, and also for all intersections, which are also automatically recognized with use of weld finder. You can see from this plot that it was automatically assigned to all the elements, taking into account all those intersections, for example. Same situation would be for Y direction. Then with use of the selector, you can specify values, shear again. So for different type of welds, you can also select different, whether it's butt weld, for fillet welds, and so on. So in this way, you can build this structure. Then when we go to the fatigue, you will see the fatigue results here again. According to DNV, you will see that the higher results are, of course, on the welds, because we had lower classes for welds. You can preview the results in a way like this. You can preview it direct just for the welds, the part which is usually most interesting. You can create many detailed views, also place them in a report automatically. One more thing which is often used in offshore structure is API, tubular member checks. So it can be also performed in quick way with use of SDC. You have possibility to adjust your resistance factors and choose, for example, all the circular tubes which should be analyzed. Additionally, you have always possibility to, for other members which are not supported with API, you can also automatically calculate them according to AISC check, for example. Sorry, and here you can see the results of tubular member check performed for beam model. Also, additionally, on the right-hand side, separate joint check, also done automatically using joint recognition and API joint check standard. Another thing which I mentioned before, where all engineers can pay attention is optimization of your structure. So SDC gives you possibility to create different rules to optimize structure by, for example, beam structure according to API, which I mentioned. So you can select possible beam properties. For example, you can select different yield of material, and software will automatically give you the best fit for a certain part of your model. So you can specify a rule that you would like to see, for example, the highest possible utilization factor below 1, for example, which meets the criteria. Same can be done for plates and for stiffeners. If we speak about DNV checks for plate buckling check or for stiffener buckling check, you can also optimize your structure with use of different plate thicknesses. Again, software will suggest you which plate thickness which you selected is the best fit in terms of your results. So you can optimize in this way weight of the structure, taking into account standard results, and also, or you can also optimize material type in this way. Same can be done for welds. So user has possibility to specify different type of welds for optimization, and then again you will see which size of the weld would be the best fit in terms of weld strength. At the end, as I mentioned, automatic reporting. You can use a ready-made template. You can use you can build your own template also. Of course, you can change your logo, fonts, colors, and so on. All the views can be stored, and you can prepare the explanation about your model, how it was built, with all the sections, with all the plate thickness, for example, and of course all the results, so something which is most important usually during our calculations. Couple of words about feedback from our customers. So here you can see a few graphs from which you can find out how much time, based on feedback of users of SDC, you can save compared to, for example, hand calculation. So as you can see, it's significant reduction of time. Same with automatic code checking and reporting, which in total, taking into account all of this, you can save around 50% of your calculation and your project time, which at the end of the day can be can result of course in in that you deliver your product quickly, and also again without an error, which I mentioned for hand calculations. To summarize, SDC Verifier is all-in-one software solution, whether it's a plugin for Ansys, so the one which we were focusing on today, whether it's plugin for any other software, or even standalone version with own interface. It gives you possibility for structural design, automation, so reduction of time, also reduce human error, because the results are always up to date with your FEM model, and also the standard verification. So no need anymore for tedious work with Excel spreadsheets, with where you have to always remember to choose correct factor, to choose correct conditions from the standards. You have everything in one place. And together with reporting, it gives you one tool for full workflow of your project. Thank you for your attention. I hope this webinar was useful for you and you found something interesting. I think we can do a Q&A session. We have still some time. So if you got any questions, please, you can drop it in the chat in the webinar window, and I'll try to answer everything. Of course, if you have any question in the future, you would like to try SDC Verifier, you can contact directly me on the email you can see at the screen. You can go to our website. I encourage you also to download the trial license. The only thing you have to do is go to the website, create an account with your email and password, and then you will be able to download it, test it by yourself, give us some feedback, or if you wish, I can also send you the link. Just drop me an email or write in the chat, and then we will contact you separately. I will wait a couple of seconds for the questions, if there are any. Okay, I think I don't see any questions for now. A couple of more seconds in case of delay, and I think we can finish this webinar. Okay, then thank you for your attention. I hope it was useful again, and speak to you soon.